With Doubtnut, get instant video solutions to all your maths, physics, chemistry, and biology doubts. Just click the image of the question, crop the question, and get instant video solution. Download Doubtnut app today.
Hello students, the question is Fe2O3 solid may be converted to Fe by the reaction Fe2O3 solid plus hydrogen gaseous. It forms Fe solid plus water gaseous, for which Kc is equals to 8 at temperature 720 degrees Celsius. What percentage of the hydrogen remains unreacted after the reaction has come to equilibrium? So in this question it is given that Fe2O3 it is converted to iron, solid iron by this reaction, for which equilibrium constant is given at temperature 720 degrees Celsius. We have to find out the percentage of hydrogen which remains unreacted if this equilibrium is attained. So if we write down the reaction first, that is Fe2O3 solid plus 3H2 gaseous, it forms 2 Fe solid plus 3 water gaseous. Now let's say at time t is equals to 0, 1 mole of hydrogen is present. We are not taking into consideration Fe2O3 because it is solid state. So no moles will be there because its concentration is taken as 1. We can say the concentration of pure solids and pure liquids is taken as 1. It means their concentrations are not affected. So we will not use them in the equilibrium constant even. So, and the products will be in 0 mole. Now at time t is equals to T equilibrium, it means when equilibrium is attained, suppose x moles of hydrogen will be dissociated. So there are 3 moles of hydrogen. So this will be minus 3x and it will be produced 0, and water which is gaseous state, so it will be produced in amount 3x. So now the Kc for the reaction is given. Kc is the equilibrium constant which is equal to concentration of the products raised to power their stoichiometric coefficient divided by the concentration of reactants raised to power their stoichiometric coefficient. Now if we write the Kc for this reaction, so Kc will be product's concentration. So product is only water we will consider because iron is present in solid state and pure solids and liquids they are not taken into consideration. So it will be concentration of water raised to power its stoichiometric coefficient, that is 3, divided by the concentration of hydrogen raised to power its stoichiometric coefficient, that is 3. Now concentration is calculated as number of moles divided by the volume of the solution or the flask in which the reaction is taking place. Let's say the volume of the solution dV. Let's the volume of flask BV in which the reaction is taking place, or the vessel, be V liters. So the concentration of H2O gaseous will be the number of moles, that are 3x. So it will be 3x divided by V whole cube upon the concentration of hydrogen, that is 1 minus 3x at equilibrium divided by its volume and raised to power its stoichiometric coefficient, and Kc value that is given is 8. So this V cube will be cancelled by V cube. So we will have 3x divided by 1 minus x whole cube. Now if this is the cube on the left hand side, so this will become the cube root on the right hand side, this is on the right hand side. So it will be 8 to the power 1 by 3 equals to 3x divided by 1 minus x. So 8 to the power 1 by 3, that is 2. So it will be 2 equals to, this is 1 minus 3x. So here it is also 1 minus 3x. So this will be 2 equals to 3x divided by 1 minus 3x, which is equals to, on cross multiplying, this is 2 minus 6x equals to 3x, or 2 is equal to 9x, and x is equals to 2 by 9, and it is equals to 0.22. Now we have the value of x, that is 0.22. It means the hydrogen which has dissociated by the x amount. So for 3 moles it is dissociated as 3x. Now we have to find out the hydrogen which remains unreacted. If initially 1 mole we have taken, 1 mole is present and 3x is dissociated, so 1 minus 3x will be unreacted. So we have to find out the percentage of that. So it will be percent of H2 unreacted, it will be, that is the amount unreacted, 1 minus 3x to the amount initial present, that is 1 into 100. Now 1 minus 3 into x is 0.22 divided by 1 into 100. So this will give us 1 minus 0.66, that is equals to 0.34. So 0.34 into 100 is 34%. It means the amount of, or the percent of hydrogen which is unreacted is 34%. So the correct option for this question is B option, that 34% of hydrogen remains unreacted when equilibrium is attained. I hope you understood the solution. Thank you.
For class 6 to 12, IIT JEE and NEET level. Trusted by more than 5 crore students. Download Doubtnut app today.